So in this video, we'll be talking about the basic structure of visual analogies, and specifically the types of visual analogies that you'll face in the caliper assessment. Please note that visual analogies are also often known as shape or figural or image analogies, but in this lesson, we'll simply refer to them as visual analogies. So here, each visual analogy problem will present two pairs of elements. So we have one pair on the left-hand side, and then we have a second pair on the right-hand side. Now you'll immediately notice the major difference between these two pairs. On the left, we have both elements revealed. So the first element in this example is simply 1, and the second element is likewise simply 2. Now that encompasses our revealed pair. On the right, we have one element, element 3, which is simply 3 as our revealed element of the pair. And then we have this unrevealed element, which is simply a question mark. And the point of this question is to determine which of our answer options, so here we have A through D, but it can also be A through F, it can be as many as 6 answer options and a minimum of 4, best fits the missing element. So let's go through this example to see a little bit more detail. So we have 1 is to 2 as 3 is to what? So we can surmise simply from the answer options that the answer is 4, but as we can see, there are actually several different types of 4, and in fact, we have 4 4s. So let's go through each one. First of all, we can notice from our revealed pair that these are letters, not numbers. It's not number 1 and number 2, it's written 1 and 2. So for this reason, we can eliminate C. We know that this is not correct. Then we have another conspicuous answer option, which is incorrect, and this is 4, not the number 4, but 4 F-O-R. So that's not a number, and therefore B is also not going to be our correct answer. And this leaves us with two answer options: the correct spelling of 4 in A, where we have all lowercase letters, and the correct spelling of 4 in D, where we have all uppercase letters. So again, in our revealed pair, we see that both 1 and 2 are written in all capital letters. So for this reason, answer option A, which uses lower cases, is incorrect, and our correct answer is D, 4 all capital letters. So 1, all caps, is to 2, as all caps 3 is to, and then again, our correct answer option, D, 4. So the point here is that the underlying logic may be diverse, but the goal is to think creatively in order to understand which answer is correct. So now let's continue looking at the same example and talk about some essentials for getting the analogy right. So here's essentially just a short set of rules that will help you, and then later we'll talk about some common mistakes and failures. So essential rule number 1 is to express the relationship between 1 and 2 in a sentence. So just to clarify, by 1 and 2, in our example here, each element is literally 1 and 2. But we simply mean elements 1 and 2, as in the elements that comprise the revealed pair. Now, it's always tempting to simply look at the revealed pair, note their differences, similarities, changes, etc., mentally, and then go ahead and try to surmise the correct answer. But it's always best practice to instead write it in a sentence. So if we consider our revealed pair here in this example, we could say something like, both elements are written forms of two different numbers where the second element is greater than the first element by 1. Now, there's a bunch of different ways that you could write the analogy, even multiple correct ways. But there is only one analogy, one correct analogy. So you must make sure that the way you are conceiving of, and therefore writing the analogy, is correct and will get you to the correct answer. And that is the whole point of writing it as a sentence instead of just noting it mentally. And if you can't confidently identify the right answer, it usually means that there's something wrong with your logic, not that the test is flawed. So in this case, if you're stuck, the right move is to go back, think about it once more, reformulate the logic, and then the correct answer will appear. Then we have essential rule number 2, maintain the order of the analogy. So this one may be a little bit confusing. What's meant by this is that 1 and 3 are in some ways a pair. 1 and 3 are related in the same way that element 2 and element 4 are related. You have to rely on the structure 1 is to 2 as 3 is to 4, and thus you must maintain the order. Then we have essential rule number 3, consider all the obvious features of the elements. Now, you can rely on the fact that there won't be any redundant features to any of the elements in any of the pairs, so nothing is worth putting aside. For example, when you first look at elements 1 and 2 in our example, you may not have noted the fact that they are capitalized, but we learned by answering the question that this is actually a key characteristic to sort through our answer options. So again, consider all of the obvious features and elements when you try to determine the logic of these analogies. Then we have essential rule number 4. Remember that there must be a correct answer. So there are no trick questions here. If you are able to look at the revealed pair and determine the logic within, then you will be able to confidently determine a correct answer. And then similarly, we have rule number 5. Remember that there is only one correct answer. So you can be sure not only that you aren't being tricked and that there actually is no correct answer, but actually there is a single correct answer. So if multiple answer options seem to fit the bill, then you may want to reconsider how you are understanding this analogy in order to get to the singular correct answer. So now let's talk about some of the most common logical mistakes in visual analogies. And we'll start with incomplete logical definitions. If you refer to an unstructured sentence or to general similarities, you are likely only to refer to a partial analogy, which may lead to undistinctive differences between the options. So, you should avoid general rules that do not focus on the analogy between 1 and 2. And we can consider an example. Let's say we were looking at a visual analogy based on shapes. So in this example, element 1 could be comprised of an outer triangle and an inner square. Then for element 2, we could have an outer square and an inner triangle. Now, if you were to describe the analogy by saying there must be a triangle, well, this would be far too general. There should always be a defined relationship between all of the major features of elements 1 and 2. And moreover, you should not ignore significant features of the elements. These questions usually do not add redundant features to sift through, so consider everything as at least potentially important. And remember, an incomplete logical definition may lead you to find potential similarities to any of the options or more than one option that fits the incomplete logic. So this is something you should take care to avoid. A second common mistake is sticking to an alternative logical definition. As a reminder, this test presents you with abstract shapes, as we can see, for example, in our revealed pair in the example on screen. And because it shows you abstract shapes, it's open for interpretation, and some people may define the analogy differently. However, you should keep in the front of your mind the fact that test makers make sure that the answer choices will include an option that completes only a single definition. So if you define an analogy that seems perfect to you, but you cannot find an option that meets your definition, then do not stick to it. You should instead drop it and rethink alternative logical definitions. So let's see an example where we keep these two common mistakes in the front of our mind and illustrate exactly where these pitfalls can be. So here we have our question, and it's in the same format as before. We have 1 is to 2 as 3 is to 4, where element 4 is what's missing to complete the pair, and this is what we're trying to determine. Now in this case, we actually have 5 different answer options, and they all try to complete that pair. Now, before we simply look at the elements 1 and 2, the revealed pair, to try to determine the right answer, let's go through a series of definitions and try to identify any problems that may be present. So we can start with definition A. There are 2 common polygons, which turn into 1 less common polygon and an inner shape. So that's referring to we have 2 common polygons in element A. We have a square and a triangle, which turns into 1 less common polygon, which is referring to this pentagon in the outer shape in element 2, and an inner dash shape, which is what we see with this triangle in element 2. Now, the problem with this definition is that it describes some differences between 1 and 2, but does not stand for a solid logical definition. And as a result, all of the options except for A and C may be considered, because only A and C have a solid inner shape. So this definition won't work. But what if we change it a little bit? We can call definition B, there are 2 common polygons, which turn into 1 less common polygon and an inner dashed triangle. Now, it's a subtle change. It changed the word shape into triangle, but this doesn't suffice. This definition is still too unstructured and allows both B and E to be considered. So this is more than one answer option, and therefore this definition will not work. Now we can move on to definition C. The inner square becomes a dashed triangle, and the outer shape becomes a polygon with a greater number of sides. Getting a little more interesting. This definition is better, and it's better structured than the previous one, but nonetheless options B and E still fit, as both the octagon, which is what we see in option B in the outer shape, and the pentagon, which is what we see as the outer shape in option E, have more sides than a square. So again, this doesn't work. But what about definition D? The inner square becomes a dashed triangle, and the outer shape of 2, so element 2, has 2 additional sides compared to 1. Again, a more interesting definition perhaps. But again, there are problems. This is the most structured definition so far, but it doesn't allow reducing the options to a single correct answer. And again, that's sort of the key giveaway that you've found the correct one. Options B and E fit the first part of the analogy, in the sense the inner square becomes a dashed triangle. We have a dashed triangle in B, and we have a dashed triangle in E, but it does not satisfy the second part. According to this definition, you would expect to find a dashed triangle inside a hexagon. On the contrary, option C fits the second part of the definition, but does not fit the first part. We see that we have a hexagon on the outside, but this is a solid triangle, not a dashed triangle. So no option fits, and therefore you may want to rethink the logic and portray it differently if you came up with this definition. Now let's go through one more definition. We'll call it definition E. The outer shape becomes the inner shape, and the inner shape becomes the outer shape, but with more sides. Again, progressively more interesting. But this definition actually misses twice. Firstly, it ignores the fact that the inner shape of element 2 is dashed. We have this dashed triangle in element 2. Secondly, it allows the outer shape of the missing element to be any shape with more sides than a square, which would allow both A and D to be true. In A, we have this hexagon, and in D, we have the pentagon. So again, we have more than one answer option that fits the definition, and therefore this definition will not suffice. So now let's go to the correct definition. The correct definition we could say as the inner shape of 2 is a dashed version of the outer shape of 1. The outer shape of 2 has one more side than the inner shape of 1. So let's go through that in context. So in element 1, we have an outer triangle and we have an inner square. So based on the definition, we would expect the outer shape, which is a triangle, to become the inner shape, and it's dashed. And that's what we see. We see a dashed triangle. And then the inner shape becomes the outer shape with one more side. So in element 1, the inner shape is a square, so it has 4 sides, and therefore the outer shape in element 2 will have one more side, which will be a pentagon, and that's exactly what we see. And this corresponds to answer option D. D is the correct answer because we have our definition. The inner shape of 2 is a dashed version of the outer shape of 1. Well, we see that the outer shape of 1 is a square, and therefore the inner shape must be a square, and a dashed square, as we see in D. Then the other part of our definition is the outer shape of 2 has one more side than the inner shape of 1. So we see the inner shape of 1 has 4 sides, and therefore the outer shape in our correct answer will have 5 sides, as it does in D. So once again, this is why D is our correct answer. So now let's move on to another common mistake, which we can call the 2 is to 1 as 3 is to 4 failure. The test makers may try to mislead you by establishing a notable similarity between elements 2 and 3. and we can go ahead and label these other elements just for clarity. We have element 1 on the far left, and we have the still unknown element 4 on the far right. Now, if they do mislead you, then this may lead you to try looking for an answer that similarly resembles element 1. In practice, it may lead you to switch the order of element 1 and 2 in forming the analogy. And if you fall into this trap, then in the best case, you will not find an answer that satisfies this faulty analogy and become confused. In the worst case, you will pick up an answer that completes this faulty analogy and lose points. And we can see this illustrated more clearly through the following example. In this example, it's option D that represents this failure, where option A is our correct answer. So now let's go through this. First of all, we can note that element 3 and element 2 are very similar. We see that in 3, we have these compound lines, whereas in 2, we have these solid lines. Otherwise, they're the same. It's 2 arrows pointing to the left. Now, as a reminder, we're calling this failure the 2 is to 1 as 3 is to 4 failure. So we're essentially talking about looking at this in reverse. Because if you see it this way, you might say, okay, well, 3 has these two, whereas 2 has these two. Again, they're the same except for the lines. And therefore, you look to 1 and say, okay, we only want one line, one less line, and facing the other direction. And therefore, you might be inclined to choose D. You have one less arrow, it's facing the opposite direction, and it retains those compound lines. But again, we know this is not the case. This is the failure. It's the 2 is to 1 as 3 is to 4 failure. So in reality, if you maintain the order of the analogy, you could define it as 2 includes one more arrow than 1 and is rotated 180 degrees. And therefore, 4 should include one more arrow than 3 and rotate 180 degrees. And that's what we see in A, and that's how we know this is our correct answer. So just to confirm once more, we have element 3, we have these 2 arrows, and we're going to include one more arrow going from 3 to 4, and they're going to be rotated 180 degrees. They'll be facing the opposite direction. So in A, we have 3 arrows, and they're facing to the right instead of the left. So we know that A is our singular correct answer. So now let's talk about one more type of mistake, which we can call the 1 is to 3 as 2 is to 4 failure. And as the name suggests, this is another faulty thinking process where one mistakenly compares elements 1 and 3 and elements 2 and 4. Now, as a reminder, the correct procedure is to compare these consecutive elements, so elements 1 and 2. Now, you should be aware that test takers may actually try to design these figures so that such a comparison feels natural and compelling. It's essentially a tool in their toolbox in order to make questions more challenging. But of course, if you fall victim to this mode of failure, if you rely on this cross-pair comparison, it can lead to an incorrect answer. So do be careful. And we'll illustrate this by working through the example we see before us, where answer option A represents this failure, and answer option C is our correct answer. So let's start by making the mistake. Let's do what we should otherwise never do and compare elements 1 and 3, and then determine the logic. So comparing the two, we see we start with a single solid horizontal bar, where in element 3, we see we have 2 horizontal bars and they are open. So the number of bars doubled, the orientation is the same, and it changed from solid to open. So then, when we try to get our correct answer by looking at 2, in order to predict 4, what would we determine? Well, we'd see 2 solid vertical bars in 2. We know we need double the number of bars, so we're expecting 4, and they're going to change from solid to open with no change in the orientation. And that's exactly what we see in A. The bars are all vertical, there's 4 of them, and they are open instead of solid. But again, this is the incorrect answer, or it is one of the incorrect answers. And that makes sense because we determine the logic by comparing non-consecutive elements, elements 1 and 3. Now, let's correct our mistake by looking at these consecutive elements, elements 1 and 2. We have this same solid horizontal bar in element 1, and then in element 2, we have these 2 solid vertical bars. So as before, we see a doubling in the number of bars, except the orientation has changed. It's gone from horizontal to vertical, and there's no change in the fill. It's still solid. So if we apply this logic to 3 in order to get 4, what would we expect? Well, we see these 2 open horizontal bars. So first of all, we're going to expect twice as many, so 4. We see that the bars are horizontal, so now we expect them to be vertical, and we do not expect a change in the fill. They should still be open. So first of all, we can eliminate B because these are still horizontal, and likewise we can also eliminate D because these are also horizontal. Then we have answer option C, which checks every box, and we already know this is our correct answer. We see we've gone from 2 to 4. They used to be horizontal, and now they're vertical, and they are still open. So once again, C is our correct answer, and you should be very mindful not to fall victim of this mode of failure just like the last. And with that, this completes our lesson on visual analogies. For more, you can visit the video description to find a link to another video lesson covering the most common logical patterns in figural reasoning.